Welcome to the mathematics in my channel. In this video we are going to solve integral from 0 to pi over 2 x square over sine of x dx, and the answer is 2 pi g. Here g we know Catalan's constant, minus 7 over 2 zeta of 3. Okay, in the previous video we solved integral from 0 to pi over 2 x times sine of x, and we had the answer 2 times g. Okay, now the different question. Well, how to begin? Okay, first here I is equal to integral from 0 to pi over 2 here x square. Now we know the complex definition of sine of x, e to the ix minus e to the minus ix over 2 times I. So 2 times I we know constant, so we can write outside of the integral sign here dx. Well, then here 2 times I, integral from 0 to pi over 2. Now I am going to multiply by e to the minus ix, both numerator and denominator. So we have e to the minus ix times x square over e to the minus ix times e to the ix, we know 1, here minus e to the 2 times ix dx. Okay, then as a next step we can use the geometric series for 1 over 1 minus e to the 2 times ix. So here we have e to the minus ix times x square. Now geometric representation of 1 over 1 minus e to the 2 minus x, we know infinite sum 0 to infinity e to the minus 2 times nxi, and here we have dx. Okay, then according to Fubini's theorem we can interchange sum, sigma notation and integral sign. So we have 2 times I, infinite sum 0 to infinity, integral from 0 to pi over 2, here x square. Now e to the minus ix, e to the 2 times nxi. So we know e to the minus ix is a common factor, so here we have 2n plus 1 and here dx. Okay, then 2 times I, infinite sum 0 to infinity, integral from 0 to pi over 2 x square. Now here we know e to the minus ix 2n plus 1, so we know the formula. E to the ix is equal to cosine of x plus I times sine of x. So we can write now this is equal to cosine of 2n plus 1 times x minus I times sine of 2n plus 1 x dx. Okay, now we can split this integral into two different integrals. So we can write 2 times I, n is equal 0 to infinity, integral from 0 to pi over 2 x square cosine of 2n plus 1 times x dx. Then we can multiply this. So we have I times I, we know I square minus 1, so here also we have minus sign, so plus 2 times infinite sum 0 to infinity, integral from 0 to pi over 2 x square times sine of 2n plus 1 times x dx. Okay, now we have our integral x square over sine of x, and this is the answer. Since the answer is real, so we know this part will be 0. So we have now I is equal to 2 times infinite sum 0 to infinity 0 to pi over 2 x square times sine of 2n plus 1 times x dx. Okay, then how to evaluate this integral? Now we can take this integral is equal to j. So j is equal to integral from 0 to pi over 2 x square times sine of 2n plus 1 times x dx. Okay, now to evaluate this integral we can use di method. So differentiation and integration. Here we have x square, so x square, and here sine of 2n plus 1 times x. Now derivative of x square we know 2 times x. Now integration of sine of 2n plus 1 minus cosine of 2n plus 1 times x. Then here derivative of 2 times x we know 2. Here integration, so minus sorry, here we should divide it by the coefficient of x, so 2n plus 1. Now here sine of 2n plus 1 times x over 2n plus 1 square. Then if we differentiate 2 constant we know 0, and here integration, so cosine of 2n plus 1 times x over 2n plus 1 cube. Okay, now we should multiply like this. So here before it, here we know plus minus plus minus. Okay, then we can write our integral j is equal to x square times minus, so we have minus x square cosine of 2n plus 1 times x over 2n plus 1, then minus minus plus 2x times, so 2x times sine of 2n plus 1 times x over 2n plus 1 perfect square, and then here plus 2 times cosine of 2n plus 1 times x over 2n plus 1 cube, and we know the limit boundaries from 0 to pi over 2. Okay, now we can apply limits, upper limit and lower limit. So here we have, now if we plug in 5 over 2 and 0, we know here 0, and here we have 5 over 2, so 2 get cancelled. Pi times sine of 2n plus 1 times pi over 2, you know, cosine of phi n we can write minus 1 to the n, so minus 1 to the n over 2n plus 1 square. Here we have here we have minus 2 times 2n plus 1 cube. Okay, then we know I is equal to 2 times infinite sum 0 to infinity 5 times minus 1 to the n over 2n plus 1 square minus then 2 times 2, so we have 4 times infinite sum 0 to infinity 1 over 2n plus 1 to the third power. Now we know here 2 times pi, so 2 times pi, and 0 to infinity minus 1 to the n over 2n plus 1 square. We know the series representation of Catalan's constant, so 2 phi g, and here minus 4 times 0 to infinity 1 over 2n plus 1 to the third power, we know 7 over 8 zeta of 3. So here 4 get cancelled, and we have 2 times phi g minus 7 over 2 zeta of 3. Okay, this is the answer. If you like this type of videos, please subscribe this channel. Thank you for watching.